All right, today we are going to go down the rabbit hole. This is an iPhone 5 with water damage that's in for data recovery. And it has a short. It has a short specifically on the main battery power rail. And we're going to go through a couple of strategies to try and hunt down where is the source of the short. So I've been working on this board for a while, and I gave up on it actually after the first time, kind of first hour or two that I put into this board. And then I've come back to it and I was able to solve it. And so I wanted to kind of work backwards through some of the strategies that I tried to finally figure out where the heck this short was located. So let's start with, let's take a look at the board. So this is the board. You'll be able to see some places where I've been working on it. So under the microscope, what are we looking at here? Let's just look for sort of signs of general corrosion. It looks pretty good. So if we look kind of across the board, the characteristic signs of corrosion are not there. Or we've got a little bit of a screw bracket problem there, but that's not going to hurt the phone. This is where I've been working. On the back of the board, it looks pretty good, especially here around the power chip. All of these little caps, they all look healthy. They all look good. So if we test with a multimeter, we'll just set the multimeter at good old regular continuity testing, which is kind of the quick and dirty way to detect a short. Let's kind of see how we're going to do this. Let's get this to sit down a little bit. All right, so we can set a multimeter on continuity testing and test for continuity to ground. So let's look at the battery connector. If I put a probe on ground and I touch to the probe itself on continuity testing, I get a beep. If I touch the ground pin of the battery connector, I get a beep. If I touch the positive pin of the battery connector, I also get a beep. This is bad. The positive pin should not be shorted to ground. It should not have continuity to ground. Let's look at a donor board here and kind of confirm that. So if I put a probe on ground, beep at the negative pin, no beep at the positive pin. There's no continuity across the battery connector itself. All right, so you should have a high resistance across the battery connector, and if you don't, that means you've got a short somewhere in your phone. So we can kind of probe around and see, what components are shorted, and that would be kind of testing, let's take a capacitor, for example. I hear a beep, one side's on ground, the other side is not, so that's good. Most of the time, a capacitor is connected only on one side to ground. If I find a capacitor that is shorted to ground on both sides, then that's bad. So that one's good, that one's good, that one's good, and that one's bad. So that means that capacitor is shorted. And since that capacitor looks reasonably healthy, we can guess that it itself is probably not the actual cause of the short. It's just on a shorted line. And once that line has a path to ground, because of some capacitor or some other component or chip that's on that line, the entire line is brought down. It's kind of like a string of Christmas lights, where if one bulb goes out, the entire strand goes out. So let's try to figure out where that short, what line is shorted. So which guy was shorted here? Let's see. So these two guys there. All right, let's look them up. Who are those guys? So we're going to head over to the schematic. And let's go back up to just page 1. And scroll on the schematic to find the board view so that we can actually see the kind of, pictorial representation of the board. Here it is. And that component, those components were on the back side of the board. And let's see if we can figure out where they were. I think they might have been C202 RF and C201 RF. Let's see if that makes sense if we look back at the microscope. Not that. If we look back at the microscope, so the shorted caps were these guys, and you can see that there's a inductor here, there's a row of 3, and they're sort of catty corner to each other with a big chip there. And let's go back to the schematic. And that's the same ones then. So there's the row of 3 inductors, and then this one over here. And then it's C201 underscore RF and C202 underscore RF. So what line are those guys on? Let's take one, C201 underscore RF, find in the schematic, and here it is. And let's drill out a little bit so we can see the line that it's on. And that guy, and here's 202, are all connected to this line here, which is called PP underscore BAT underscore VCC and then connector. So if we take the time to kind of search for the schematic for that line, PP underscore BAT underscore VCC underscore connector, we will find it in a couple different places. So here it is going into a baseband chip here. Here it is going into another baseband chip, and there's a capacitor hanging off of it there. Here it is going into this U1201 chip, and you can see on that same line are lots of these different components, any one of which could actually be causing the short. And then PP BAT VCC connector is a branch of the line PP BAT VCC. And if we follow that line around, we can see it appear in lots of places. So there's lots of places in the schematic where this power rail is used to power on a couple different chips. Here it is here at the going into the main power supply, and you can see that the BAT VCC line, the main battery rail, is connected to PP VCC main, the main power rail for the device, through this transistor Q4. And that allows your iPhone to take power either from the battery or from the USB charger. Well, here's a place. Here's that same line going into the speaker amp. And look at all this 1, 2, 3, 4, 5, 6 capacitors that could potentially be shorted, or maybe the speaker amp chip itself is shorted. So we don't know where is the cause of this actual short. So let's start here at the battery connector. So the battery connector has a negative pin, which we tested, and then it has a positive pin, which is that PP BAT line. And this line should not have continuity to ground, but it does. So it could be any one of the other places, or it could be right here. Kind of these caps are local to the battery connector. So that kind of, you know, is our work that's kind of cut out for us. So how do we figure out, you know, if we could sit here and it would take a really long time to kind of use method number 1, which would be just brute force. We could, like searching for which bulb is bad in a string of Christmas lights, we could just start taking components off. We could find, you know, the first one, C9, take it off and see whether or not the short still exists once we remove that bad bulb. If it does, then it wasn't that one. Put it back, try another one. So you could kind of brute force your way through this, but that would really be not feasible. It would just take too long, and it would exceed the value of probably even the data that's on the phone to do it like that. So what's the next strategy? The next thing would be to kind of let the damage be your guide. And this is why it's always important, after you take the shields off, to look at the board before you do ultrasonic cleaning, to give yourself a hint, where is the corrosion worse? You know, where was the board really hit hard when the original water damage event happened. So on this board had some serious damage here at the battery connector area, which I've been working in this area, so you can't really appreciate that anymore. But here at C9, for example, this component was just really entirely corroded and gone. Oh, thank you, sweetheart.
Well, this is one of your Macy's, one is Dad's.
Okay. Thank you very much. I will put it on right now. Mother's Day gift. All right, so C9 then was annihilated. So from the sort of strategy of look for what is the worst looking component on the line, it would have been C9. So I was hopeful that that was itself going to be the shorted capacitor. So I knocked it off, and you can see that even the pad that that component sits on is completely blown away. So, and so is the trace. So the trace has gone all the way up to there. And unfortunately, even with that component gone, this area is still shorted, so that didn't help. So I looked around the board. I found another spot over here on the back side of the board. There was another particularly bad looking component that I took off, but the short was still there. This guy I took off and the short was still there. And I knew that I could take these guys off without really a lot of harm, because this is a data recovery job. And again, you guys know that I don't fix water damage for the sake of the phone, and you can see why, because it's just way, way, way too laborious to not only find and remove the short, but then also to replace all of the damaged components so that the phone's going to work again. You know, that's just way too much when you can just go replace the phone. But for data recovery, it makes sense, and it's a great way to learn. So that didn't help. All right. So what's my next strategy then? Let's say that the brute force method we're not going to do. And then number 2, look for the worst looking caps. That didn't work in this case. So number 3 is let's try to use kind of an intelligent approach to try to kind of deduce which capacitor, or at least kind of get us close to the short by using this new little tool that I got. So this thing is called the Half Ohm. And I just got this thing. And this was designed by a Estonian guy, and I ordered it from him. And it's a little hack, and I'll show you his website. So here's his website, and here's this guy's name, which I won't attempt to pronounce. And so he makes these things, and they're a really great little concept where the idea is, in theory, in a shorted circuit where many components are going to be shorted, but only one is the cause of the short, that if you were to measure the actual resistance to ground at the shorted component, you would have extremely low resistance to ground, like 0. And then if you were to measure another component that's also shorted to ground, but at a distance from the actual component that's causing the short, you might measure some tiny amount of resistance. And if we had an ability to actually measure resistance in milliohms, not just ohms, but milliohms, then we might be able to kind of just use measurement to figure out where the short is. So this little half ohm thing is an adapter for your multimeter, and I will show you how it works, at least in theory. I haven't really had a chance to play around with it that much. So it has a little on-off switch that will make a little LED light shine so that you can see that it's on. You attach it to your existing multimeter, and it will turn your multimeter into a sort of precision multimeter. Then you set your multimeter, and you'd think you'd set it on ohms to measure resistance, but you actually set it on millivolts, and it will show up as milliohms of resistance. All right, so then we'll touch our probes together, and it reads 0 milliohms, and then we can measure around. So let's say, let's detect resistance to ground. So let's put a probe on ground and measure here at the actual battery connector negative pin. And it's kind of jumping around a little bit. It looks like 7.4 milliohms. So that can kind of maybe be like the baseline. When I touch the probes together, it was saying 0, but now it looks like 4.2. And then we can kind of measure, one of these. Let's look on under the microscope with me. measure one of these shorted spots. So this component is shorted, and it's reading that same like 4.5. And then if we measure somewhere else, like let's measure over here, the C202 and 201. One side is 6.2, the other side is 8.5. So one side like is ground. Yeah, so that's like 8. So from here, you know, you could, at least in theory, play around with this tool and use it to detect a slight variation, the difference between 4 milliohms and 8 milliohms and 12 milliohms, to kind of work between this measuring device and the schematic to figure out which, you know, where the short most likely is, close to the battery connector, close to the speaker amp, close to one of the baseband chips, you know, and kind of go that way. So I tried that for a while, but I wasn't really getting anywhere, and it was taking longer than I wanted to spend on that. So we're going to kind of put that aside for now. So the half ohm is another, at least potential strategy. I'm not 100% sure that it's going to be useful for iPhones, but maybe it will. Okay, so then now what are we going to do? So now we need a new plan. So brute force isn't going to work. Find the worst looking component didn't work. The half ohm method didn't work. What else can we do? So we can take advantage of the fact that the board can kind of tell us a clue on where the short is located because of heat. So a short circuit is an inappropriate path to ground. When you have electrons racing through, instead of having to go through all the resistance of all the circuitry of the phone, they're going to go through really fast, and that's going to consume an unusually high amount of current. And so when you've got a lot of electron flow really quickly, that's going to generate heat. So we can just hook up the board to a power supply and let it have some current and see if we can figure out where it gets hot. So I have, you know, you guys complain about me soldering leads onto the battery connector, but that's the way I like to do it. I like to see it actually make that connection and not rely on a third-party, all these little third-party adapters. So I have soldered on the, you know, positive and negative lead to my DC power supply, and I'm going to set this to like a standard 3.8 battery voltage. Hit go, and it's going to give me the option to sort of limit the current. So I'm going to set a limit of 800 milliamps. So when I tell it to limit the current at 800 milliamps, the thing only takes half of a 0.4 of, you know, 1 volt. So it has a very strong short to ground. And in my experience, the normal, you know, these normal phones typically run consuming about 200 to 400 milliamps. So 800 milliamps is definitely a short. That's inappropriately high. A normal phone really doesn't consume that much current. So with 800 milliamps running through here, usually you can feel the heat. You can find it. So you can use your fingers to just sort of feel for heat. And if you can't find the short, then you can use, you know, something more sensitive like the side of your face or your lips, which I use, you know, a lot, or other parts of your body that I've heard other people use. Haven't tried any of that. And, you know, if you're not feeling the heat, then you can help yourself out. Like, what else could we do? Let's use some alcohol. So we can put some alcohol on the board, and alcohol will boil off the board wherever it's hot. So we'll look for like bubbles and alcohol blowing. Another thing that we can do is, let's go ahead and stop this current. Another thing that we can do is try using some freeze spray. So we'll freeze it down. And let that get cold for a second. Let's look at this. A lot of people ask me, like, how can you freeze a board and run electricity through it? The stuff that's in this can is some, you know, hydrocarbon that does not conduct electricity. So you can use that magic. All right, so now we've got a frozen board. let's hit it with some juice and see if we can see anything light up. All right, so now it is consuming the 800 milliamps, so we should be able to see a hot spot. Something should melt. And a lot of times with a short, you'll see it right away. Oh, look at that compass I see. So right there, you know, that's a potential candidate. The compass I see there looks pretty hot. I've already been working in this area. You can see I've taken off the Wi-Fi chip. All right, so that can sort of give us a clue. All right, so that's one way of doing it. Let's see whether or not that compass IC is actually shorted. So this board I have been working on, and I actually found the short, pulled it off, and the phone booted as normal, so I already got the data off of this phone. So I'm just kind of putting it back together for this guy. And it actually wasn't the compass IC. So let's try that again. Let's see if the compass IC really is the hot spot. So let's take a look at it. Hit the juice and see if that is getting hot or if that just kind of didn't ever get freeze spray. So this really isn't helping me out today a whole lot. You know, there might be something shorted around this camera connector. But usually, you know, something will pop up. It looks a lot hotter down here. All right. So I'm going to conclude, and this is the same thing that I concluded the first couple times that I did this, that today the freeze spray method is really not helping us figure out where the short is. So I'm going to throw some alcohol on this board just to kind of rinse off that stuff. And let's go for another method. So if the board is not getting hot enough to use freeze spray to kind of show us where the short is, then it's definitely not going to get hot enough for an alcohol method to show us where the short is. So that's not going to work either. So now we're really kind of getting to the bottom of the barrel of our potential strategies. So I have set the DC power supply to limit it to 800 milliamps. But I've also removed some components on the board to isolate the battery main power rail from the VCC main power rail so that I'm going to try to say what happens if I just feed more power into that short. Something will get hot. You know, if I put if I put enough current through there, something will get hot. So let's just increase the limit and see if we can actually set something on fire. You can add so much current that you'll blow a short right out of the board. That's pretty dangerous. So this isn't something that I would do unless it was sort of a last resort. And since I already have the data off of this board, it's just kind of a fun project. So let's see if we can detect the short. First, let's make sure the short is still there. So we will just kind of confirm that with a multimeter. Yep, it's still shorted across the battery connector, so that line is still short. So now we'll put a little alcohol on the board, because if we put in enough current flow to get something hot, then it will fry up the alcohol. And let's look under the microscope and see if we can see what's going to happen. Okay. Let's turn it back on, and now let's increase that amperage. 1 amp. 2, 2.5, 3 amps, 4 amps. Let's look and see if we can see anything sizzling. So now we are feeding 2 volts, 4 amps into this short. So something is going to get hot. Declare yourself. I don't see anything happening. I don't see any, like, little bubbles and bubbling that I would expect. We want to see smoke. All right, let's give it a little bit more. All right, so it finally got up to 3.8 volts with 7 amps. That's a lot. You can feel the heat in the wires coming from the power supply. The board is cold up at the top. Yeah, I'm feeling some heat right here. Let's try to see where that heat is. Let's try to put some more alcohol on it. Alright, I'm seeing some bubbles. There we go. Look at that. There we go. So that's where the short is. It's either this chip, it's either this chip here or that local capacitor. All right, let's throw some more on there. Yeah, that's getting hot right away now. This end of the board is just drying off, and I can see the bubbles. All right, so that looks like where our short is, and it's, a little less dramatic than it can be sometimes. So I can see the short is most likely at this capacitor, and it really helps me out because I know that that's where I found it before. And so I just kind of put it back for this sort of example. So I'm turning off my power supply, and I'm going to just pop that guy off the board. Hope that's not on D. Hey, I'm doing a video. All right, I'm just going to clean up the pads here that were under that cap. Now this was the cap that I found earlier when I did this the first time, and it looked perfectly normal. That's why this was a difficult one to find. But eventually, if you use lots of different strategies, you can have your way with shorts. Okay. Oh, so let's take a look at that. So now that component is gone. So I removed that little capacitor, and let's see if that was enough to relieve the short, or if our process has, shorted something else out. All right, so we're going to do multimeter test. ground to ground pin, and ground to positive pin, no more beep. And let's measure resistance across here, no beep. Awesome. So that means that we have officially found the short and relieved it. It was that little capacitor, and we could, look up on the schematic exactly, what the culprit was. I kind of want to do that. Let's look him up. So let's go back to the board view page. And it was on the other side. It was C1201_RF. So what line is that guy on? C1201_RF. Let's find it. And here it is on the PP_BAT VCC connector line. It is just one of these guys, and it could have, it could have been anything on any of these lines. All right, let's go back to, a regular view. Okay, so now we have officially relieved the short. Looks like I got to stick on one of my DC power supply leads again. Whoops. All right. Okay, so now let's test for function. So this has got alcohol on it. I'm going to blow it off. Okay, so now with the short gone, at least in theory, we should be able to see if we can get this phone to power on. So let's go ahead and connect the screen. All right, so we've got a screen. Now this thing's not going to boot unless we tell it to boot, at least in theory. So let's put back on the power, and it's consuming no power because it's not been prompted to boot. So this is the normal case. For a board, you hook it up to a DC power supply or a battery, nothing happens unless you hit the power button or you connect it to a charger, which will prompt the phone to boot. So let's prompt the phone to boot by connecting it to a charger. So I'm going to turn this off for a second and connect my charge port. This charge port is connected to the computer. Now I'm going to hit my battery back on, and Apple logo. Let's see if it'll actually boot, or if we've played too hard here. And so, shorts in water damaged phones are great because if you can find the short, you can relieve the short, and then a lot of times, I hear connect sound, a lot of times the phone will work as normal. So iTunes is telling me that it's detecting it, and there we go. All right, so we're back into this phone. So this one is solved. So, we can get the data. I already did that. So I will be kind of putting this phone back together, and it's going to be good news for this guy. And hopefully you guys have some strategies that you can use when you're trying to do water damage short detection. And that's it for today.